Hello, friends of NeoTech 4000. Today is the story of a forgotten Daewoo Cielo. The young mechanic walks alone into an overgrown field where the car has sat motionless through countless seasons of rain and sun. The cabin is buried in dust, the seats are rotten, and dampness hangs in the air. Yet she can still see the outline of its former glory. The former owner says softly, "It doesn't run anymore." The young woman simply asks, "How much do you want for it?" The final price is $500, almost the value of scrap metal. Do you think she is buying a bargain or a burden? Before taking the car, she checks the pressure in every tire. Long-term underinflation can damage both the sidewalls and the steel rims. The valve stems are brittle, the tread is cracked, and the wheels are beginning to rust. She records every fault, because a good restoration always begins with diagnosis. Grass has wrapped around the underbody and nearly pinned the car to the ground. She must clear a path before even thinking about moving it. She crouches to inspect the rocker panels and jacking points. If the load-bearing metal is rotten, the body could deform when lifted. After repeated inflation and careful wheel movement, the Cielo begins to shift. It is the car's first movement after years of silence. The car is brought back to her small workshop. There is no elegant signboard here, only tools and hands hardened by work. The hood opens to reveal an engine bay covered in dust and rodent nests. Chewed wiring is now the most serious fire hazard. She does not rush to connect power or crank the engine. An engine left idle for years can seize if it is forced to turn. She checks the oil, coolant, and every trace of leakage. Each stain is a testimony left behind by the old car. Inside, she removes the front seats to expose the floor. Moisture often corrodes steel beneath the carpet where the eye cannot see. The gear lever, handbrake, and dashboard controls are all inspected. She wants to know whether time ruined the car or an old accident did. Every section of carpet is pulled out of the cabin. Dirt, dead leaves, and rodent waste have turned the interior into a health hazard. The steel floor appears with several rusty areas, but its structure is still intact. It is the first piece of good news in her long day. Orphaned as a child, the young woman had no one to rely on. Mechanical work was once the only way she could support herself. That is why she understands being abandoned better than most people. Perhaps that is why she cannot turn her back on this cello. Cleaning foam covers the glass and the entire body. She softens the moss first to avoid scratching the metal beneath it. The windshield is scrubbed one small section at a time. Clear visibility is a safety requirement, not merely a cosmetic concern. She washes from the roof downwards so dirt cannot run back over clean panels. It is a small habit that saves a great deal of time. Hardened mud around the wheel arches is soaked thoroughly. If left behind, it will trap moisture and continue corroding the fenders from inside. High-pressure water gradually strips away years of moss. The old white paint appears in patches, like memories from another life. She focuses on the door edges and body seams. These are the places where water often collects and hidden rust begins. All four doors are cleaned through every drainage opening. Blocked drains can hold water inside a door for months. The rear of the car carries the thickest layer of oil and soil. She uses a soft brush so the brittle plastic parts will not crack. As the dirt disappears, dents and corrosion become visible. The car can no longer hide the years it spent neglected. She carefully washes the underbody and rocker panels. This is where she will learn whether the car is worth saving or only worth scrap. The rear wheel turns heavily, suggesting that the brake may be seized. She notes that the hub and wheel cylinder must be dismantled and inspected. The hood is clean, but the paint is peeling away in large sections. New paint means nothing if the metal beneath it is still unstable. Black water runs from the body as though carrying years of neglect away. She says nothing, but the weight in her eyes begins to ease. The Cielo is positioned at the exact center of the lift. Incorrect support points can bend the floor or let the car slip during work. She opens the door, confirms the gearbox is in neutral, and applies a handbrake. Every safety step must be completed before lifting the vehicle. All four lift arms are aligned with the reinforced points. She raises the car only slightly first to make sure it remains balanced. As the car rises, rust, oil, and mud across the underbody are fully exposed. This is where the real restoration finally begins. Using a work light, she inspects the cross members, brake lines, and fuel lines. One rotten pipe could turn the first road test into a disaster. No chassis remains perfect after years outdoors, but the Cielo's main structure is still strong enough to save. She exhales and says, "All right, let's begin. Do you believe this car will drive again before these 97 minutes are over?" She removes the lower shields to gain access to the engine assembly. Rusty bolts are soaked with penetrating oil first to prevent broken heads. The engine bay is examined from below. Oil around the seals shows that the engine has been leaking for a very long time. She disconnects the negative battery terminal first. This is a mandatory rule when working on an old electrical system. Electrical connectors and vacuum hoses are carefully labeled. A small tag now can prevent hours of troubleshooting during reassembly. She removes the intake pipe and coolant hoses around the engine. Aged rubber must not be reused simply because it still looks complete. The alternator, belt, and pulleys are checked for play. A noisy bearing or misaligned pulley can destroy a new belt very quickly. The spark plugs are removed to reduce resistance when turning the engine by hand. Their tip colors also reveal the combustion condition of each cylinder. She uses a tool to rotate the crankshaft manually. The fact that the engine still turns means hope has not disappeared. An external battery is used to test the basic circuits. She avoids extended cranking because proper lubrication has not yet been restored. The front wheel is removed to access the brakes and drive shaft. The wheel nuts are loosened while the car is still securely supported. The brake disc is deeply rusted, and the pads are stuck in the bracket. She will not let the car move until the braking system has been rebuilt. She removes the caliper and suspends it with a wire. A caliper must never hang by its flexible brake hose. The drive shaft and ball joint are checked for looseness. Grease escaping from the rubber boot shows that the CV joint has lacked lubrication. The opposite wheel is removed using the same procedure. She always works symmetrically so no detail is missed between the two sides. Underneath the car, the engine and gearbox connections are gradually separated. Every bolt is sorted by assembly rather than thrown into one tray. The engine mount is rusty but not cracked. She marks its original position so alignment will be more accurate later. Old engine oil and coolant are drained into separate containers. The thick black fluids show how long the car has been abandoned. She examines the metallic residue at the bottom of the oil. Too many bright particles could mean severe crankshaft bearing wear. The engine hoist is positioned in front of the car. The lifting points must be balanced so the engine cannot rotate unexpectedly. She checks every wire, hose, and engine mount once more. Anything still connected could be torn apart when the powertrain leaves the bay. The chain is tensioned gradually until it begins carrying the load. She watches the mounts and gearbox before lifting another few centimeters. The engine assembly begins to separate from the body. It is a tense moment, because one wrong angle could bend the firewall. She operates the hoist while guiding the assembly by hand. Experience is shown through patience, not through using excessive force. The engine and gearbox come out together as one unit. The empty bay reveals the true scale of the work ahead. She lowers the entire powertrain onto a low trolley. The weight must sit between the wheels so the trolley cannot overturn. The remaining old wiring is tied neatly to both sides. She will inspect every rodent-damaged section before the engine returns. The engine bay is coated with degreasing solution. Old oil must be removed before wheel cracks and leaks can be seen. Rush reaches every corner around the strip towers. Rust here is dangerous because it directly affects suspension geometry. The white foam gradually turns dark brown. What runs onto the floor is a mixture of oil, soil, and years of neglect. She uses moderate water pressure around the electrical wiring. Excessive pressure can force water into connectors and create difficult faults later. After washing, the engine bay is dried with compressed air. Moisture trapped inside a connector can cause oxidation overnight. She stares at the empty space in silence for a long time. As a child, she once slept in a repair shop in exchange for learning a trade. No one taught her with gentle words. Burns, cuts, and costly mistakes became her instructors. The engine is mounted on a dedicated rotating stand. The stand lets her reach the underside without working in a dangerous posture. She removes the external accessories before opening the engine itself. The alternator, power steering pump, and brackets are inspected separately. Corroded bolt heads are cleaned before an impact wrench is used. The socket must fit tightly to avoid slipping and rounding the edges. The intake manifold is removed from the cylinder head. All deposits in the ports suggest a crankcase ventilation system once worked poorly. She separates the heat-stained exhaust manifold from the cylinder head. Exhaust studs break easily, so force must be increased slowly and evenly. The valve cover lifts away, revealing thick oil sludge. It suggests that oil changes were delayed or poor quality lubricant was used. Do you think an engine this dirty is still worth rebuilding? For her, the answer can only come after every component is measured. She removes the camshaft and rocker mechanism in the correct order. Parts that have worn together must return to their original positions for comparison. The cylinder head bolts are loosened in the reverse tightening sequence. Doing it incorrectly can warp the aluminum surface as stress is released unevenly. When the cylinder head separates from the block, 4 combustion chambers appear. Heavy carbon deposits show that combustion had become inefficient. She examines the cylinder walls under angled light. Deep vertical scoring would require boring or replacement cylinder liners. The oil pan is removed to reach the crankshaft. Sludge at the bottom cannot be washed away simply by adding fresh oil. She removes each connecting rod cap and marks it clearly. The caps cannot be swapped because each one was machined with its own rod. The first piston is pushed out of the cylinder. Carbon-seized piston rings explain why the engine once suffered low compression. The remaining pistons are removed one by one. She checks the skirts, ring grooves, and any signs of abnormal contact. The crankshaft bearings are scratched, but they have not turned blue from heat. The engine once lacked oil, but the surfaces never welded together. She lifts the crankshaft from the block with both hands supporting it evenly. The journals must be measured. Eyesight alone cannot determine their condition. A micrometer is used to measure every crankshaft journal. A difference of only a few hundredths of a millimeter can reduce oil pressure. The oil pump is removed and opened for inspection. Excessive gear clearance prevents it from building pressure at low speed. The water pump and all old seals are discarded as well. A partial rebuild would only force her to remove the engine again. Every component is arranged in groups across the floor. Organization helps her see what is missing before reassembly begins. She sprays degreaser over the block and the engine accessories. The chemicals need time to break down deposits and cannot be rinsed off immediately. Pressurized water removes years of oily sludge. She protects all machine surfaces from scratches and trapped moisture. The oil pan is scraped clean of old sealant. Its mating surface must be perfectly flat so the new seal will not leak within days. The pistons are soaked while their ring grooves are brushed clean. Remaining carbon could seize the new rings during the first startup. She blows every oil passage clear with compressed air. Even one small particle could travel directly into a new bearing. The old engine now lies in hundreds of pieces. Sometimes saving something requires the courage to take it completely apart. She turns to the manual gearbox separated from the engine. The burnt smell of its old oil suggests prolonged internal friction. The gearbox casing is washed before it is opened. Cleaning the exterior prevents dirt from falling onto the bearings and gears. The casing bolts are loosened evenly around the perimeter. Old aluminum can crack easily if one side is pried open with a screwdriver. The gearbox cover comes away, exposing the gears and differential. She inspects the metal debris collected on the magnetic drain plug. Fine particles indicate normal wear, but large fragments are a warning. Fortunately, she finds no broken gear teeth. She rotates each shaft and listens to the bearings. A gritty sound or a tight spot indicates pitting on the bearing surfaces. The synchronizer teeth are inspected for wear. This mechanism determines whether each gear engages smoothly and accurately. She examines the differential spider gears. Excessive play would create a knock when shifting between forward and reverse. The hardened old driveshaft seals are removed. New seals cost far less than removing the gearbox a second time. Old gasket material and sealant are scraped from the casing surfaces. No fragment can be allowed to fall into the internal lubrication passages. The serviceable bearings are washed and dried at low air speed. Spinning a bearing too fast with compressed air can damage it. She applies a thin layer of assembly oil to the gears. Metal surfaces should never begin operation completely dry. The two halves of the gearbox casing are test-fitted for alignment. One misplaced locating dowel is enough to keep the housing from sealing. The bolts are tightened diagonally with even torque. She avoids an impact wrench at the final stage because aluminum threads strip easily. The selector is moved by hand through every gear. Engagement must feel positive, without binding or jumping out. She sets the repaired gearbox aside. One of the hardest sections is complete, but the car's heart is still open. The dry engine block receives a light coat of corrosion protection. All mating surfaces are masked so no chemical can contaminate them. She cleans the threads in every bolt hole with the proper tool. Dirty threads can produce false torque readings even when the wrench is correct. Every component is arranged in reverse assembly order. That is how an experienced mechanic reduces mistakes while working alone. Night has fallen outside the workshop, but she still has not stopped. No one is waiting for her at home, so work is often where she stays longest. The next morning, she begins by wiping the cylinder bores again. The white cloth must remain perfectly clean before the pistons go in. The crankshaft is placed onto bearings coated with assembly lubricant. She turns it gently to confirm there are no abnormal tight spots. Each main bearing cap is installed according to its mark and orientation. One reverse cap can lock the crankshaft as soon as it is tightened. A torque wrench is used in several gradually increasing stages. Correct torque keeps the oil clearance consistent along the entire shaft. The new piston rings are checked for end gap inside the cylinders. Too little clearance can make them expand, bind, and break when the engine heats up. She positions the ring gaps in the specified directions. Aligning them would allow combustion gases to escape quickly into the crankcase. The first piston is compressed with a dedicated ring compressor. She taps it gently with a wooden handle to avoid damaging the piston crown. The other pistons return to their correctly marked cylinders. Each connecting rod must face the right direction to avoid contacting the crankshaft. Every rod cap is paired correctly and tightened to specification. After each piston, she rotates the crankshaft to check resistance. The oil pump is installed with a new gasket and seal. She primes it with oil so it will not have to draw dry during the first crank. A thin, continuous bead of sealant joins the oil pan to the block. Too much sealant can squeeze inward and block the oil pickup screen. The block deck is cleaned without aggressive abrasion. Even a small depression could prevent the head gasket from sealing. The new head gasket is placed over the locating dowels. No extra sealant is used unless the manufacturer specifically requires it. The clean cylinder head is lowered straight into position. Sliding it sideways could damage the new gasket before the bolts are tightened. She tightens the head bolts from the center outward in sequence. This distributes clamping force evenly and helps prevent warping. The valves are tested for sealing with solvent. Any leaking chamber must be corrected before the engine is closed. New valve stem seals are pressed onto every guide. Hardened old seals commonly cause oil consumption and blue exhaust smoke. The valve springs and keepers are installed with a spring compressor. She checks every keeper because one loose piece could destroy the engine. The camshaft is placed in position with plenty of assembly lubricant. A dry cam journal can be scored within its first few revolutions. The rocker assembly returns to its original position. She adjusts the clearances so the engine will run quietly and the valves will seal. The valve cover is installed with a new gasket. She tightens it only enough because excessive force can distort the cover and cause leaks. The camshaft drive and timing belt are aligned with their marks. One tooth out can cause low power, hard starting, or valve contact. She turns the crankshaft through 2 complete revolutions by hand. This is mandatory before the starter motor is ever allowed to operate. The crankshaft pulley and accessory pulleys are reinstalled. The tapered surfaces must be clean and free of oil to maintain clamping force. A new water pump and gasket are secured in place. A weak cooling system would destroy all the work invested in the rebuild. The alternator is mounted and the pulley alignment is checked. A misaligned belt will wear at the edges and begin to squeal. The intake manifold is installed with a new gasket. She checks the flange to prevent vacuum leaks and unstable idle speed. The exhaust manifold returns after its mating surface is cleaned. A leak near the cylinder head is noisy and can also distort sensor readings. The contacts on the old sensors are cleaned carefully. Oxidized connectors can make a healthy engine behave as though it is failing. The distributor and high-tension leads are checked against the firing order. Swapping only 2 wires can make the engine backfire and shake violently. New spark plugs are tightened to the correct torque. Over-tightening can damage the aluminum threads in the cylinder head. The gearbox is moved back toward the engine. She aligns the input shaft precisely with the clutch disc before joining the housings. Bolts must never be used to pull two misaligned assemblies together. Doing so can bend the clutch disc or damage the input shaft bearing. Only when the mating faces meet naturally are the bolts tightened. The powertrain is finally a complete unit again. She installs the starter motor and checks its heavy power cable. A loose connection creates heat and weak cranking even with a good battery. The drive belt is tensioned to the correct deflection. Too loose and it slips. Too tight and it damages accessory bearings. She rotates the complete engine one final time. The smooth, even sound confirms that nothing inside is making contact. The clean powertrain stands before the empty car. She whispers, "It is time to put the heart back." Rain suddenly falls outside, recalling the cold years the car endured. But inside the workshop, she continues alone. Should she keep this cello as a memory, or sell it to someone who truly understands the value of a second life? The engine assembly is placed on a trolley and moved beneath the front of the car. She chooses to raise the body so the installation angle is easier to control. The hoist takes the weight while she guides the gearbox away from the firewall. Every centimeter must be watched from several directions. The first engine mount catches its threads but is not fully tightened. She leaves the other points free to move so the assembly can center itself. The gearbox mount and rear mount are installed in sequence. Only after the powertrain rests naturally does she tighten them to specification. The drive shaft is pushed into the differential until the retaining ring locks. If it is not fully seated, gearbox oil will leak as soon as the car moves. The ball joints, tie rod ends, and hub assemblies are reconnected. New safety pins replace the old corroded ones. The engine wiring harness is routed along its original path. She keeps every wire away from the exhaust manifold and sharp body edges. The labels on each connector make reconnection much faster. That is the reward for being careful from the moment the engine was removed. Age sections of coolant and vacuum hose are replaced. Even a tiny leak can cause unstable idle speed or engine overheating. She installs the intake ducting and tightens every hose clamp in place. An intake leak creates a lean mixture and difficult starting. Fresh engine oil is poured through a clean funnel. She selects a viscosity suited to the clearances of an older engine. The gearbox also receives the correct quantity of new oil. Insufficient lubrication would make the bearings howl on the first drive. Coolant is added slowly to reduce trapped air. She opens the bleed point and squeezes the hoses to force bubbles out. A temporary fuel supply is used for the first test. The old fuel in the car may have degraded and could block the injectors. She removes the fuel pump relay and cranks the engine to build oil pressure. The engine must not fire until oil has reached every bearing. The oil warning light goes out, confirming that pressure has developed. She reinstalls the relay and performs one final check around the engine bay. The key turns, and the starter begins to pull the engine over. The Cielo coughs several times but still refuses to wake. She stops immediately to check the ignition wire order and fuel supply. Continuous cranking only overheats the starter and hides the real cause. On the second attempt, the engine fires and shakes violently. She adjusts the ignition timing while watching pressure, temperature, and leaks. The engine node gradually becomes steady inside the small workshop. Years of silence end with the sound she has waited to hear most. She holds the engine at low speed while the new surfaces begin to bed in. The initial run-in requires stable temperature and no heavy load. She listens for knocks and squeals while watching the exhaust smoke. A skilled mechanic often hears a fault before an instrument can report it. The cooling fan operates, and the temperature remains within limits. She performs another inspection before shutting down and retightening connections. The car's heart is alive, but the body is still covered in scars. She decides to restore the entire vehicle instead of merely making it run. A heat gun softens the peeling white paint. Careful heat makes the coating flexible without warping the thin steel panel. She uses a scraper to lift each section of old paint from the roof. Underneath, the corrosion spreads farther than it first appeared. Years of sun and rain have destroyed nearly all protection on the roof. Painting over it would let the rust return within months. The old coating falls away like discarded scales. She remembers that she, too, once had to leave the past behind to survive. The side door is inspected by touch and under angled light. Ripples reveal that the body was once struck and repaired carelessly. A grinder exposes clean metal around the worst corrosion. She keeps the tool moving so the thin sheet steel cannot overheat. Small holes appear in the front fender after the paint is removed. Rust perforation cannot be hidden with filler. Weak metal must be removed completely. She taps gently around each hole to find where solid steel begins. A dull sound warns that the metal underneath has become thin. Door edges, window channels, and body creases are cleaned by hand. A large grinder is unsuitable where the original shape can easily be lost. Paint peels from the rear quarter in several thick layers. It shows that the car was repainted before without proper preparation beneath it. She removes the entire pour repair instead of preserving it to save time. Starting again is slower, but it is the only way to create a durable finish. The trunk lid and fuel filler opening are carefully inspected. Moisture often hides behind seals and corrodes the metal from inside outward. She switches to a random orbit sander on the broad panels. Its offset motion reduces deep swirl marks in the bodywork. Each section is sanded from coarse to progressively finer grits. Skipping too many grades leaves scratches that become obvious under clear coat. The white paint disappears, revealing old colors and bare steel beneath. The car looks worse, but it is actually moving closer to the truth. Would you paint over everything for speed, or strip it properly as she does? The right decision is rarely the easiest one. She removes paint and rust from the entire side with grinders and sandpaper. Corroded areas must be cleaned until the remaining metal is bright and solid. The roof is sanded in long, even passes. Excessive pressure can create low spots and distort reflections across the surface. She checks the panel with a straight edge after every stage. Dust and workshop lighting can easily deceive the naked eye. The front fender is shaped carefully around the lamp opening and body crease. Preserving a sharp original line separates a skilled body technician from an average one. Every bare metal area is wiped with a degreasing solvent. Even fingerprints contain oils that can weaken primer adhesion. Compressed air clears dust from door gaps and window channels. Trapped particles can escape during spraying and ruin the finish. The rear door is sanded until no lifting paint edge remains. The transition must be smooth so the new finish does not reveal a visible step. The trunk lid and rear quarter are also leveled and reshaped. She studies the body from several angles to find every shallow dent. The windshield is cleaned before masking begins. Tape cannot adhere reliably to a surface contaminated by dust or wax. Paper and plastic sheeting seal the entire cabin. Primer overspray inside the car would cling stubbornly and be difficult to remove. The tape edges are pressed deeply into the window seals. Clean masking produces a sharp border instead of a jagged paint edge. The wheels are fully covered to protect the tires and brakes from overspray. She leaves only the space required to reach the wheel arches. Handles, lights, and any components left on the car are masked carefully. Paint preparation often takes longer than spraying itself. She mixes the anti-corrosion primer with hardener at the specified ratio. An incorrect mixture can leave the coating too soft or brittle enough to crack. The spray gun is tested on a sample panel to adjust the fan and fluid flow. The pattern must be even at both ends, without a heavy spot in the center. The first primer coat is applied lightly as a bonding layer. Spraying too heavily at once can cause runs and trap solvent underneath. She holds the gun perpendicular and at a constant distance from the body. Changing the distance creates uneven thickness and inconsistent color. Each pass overlaps the previous one by approximately half. This technique creates complete coverage without visible stripes. The body gradually turns a blue-gray primer color. For the first time, its old wounds receive genuine protection. She pauses between coats to allow the primer to release solvent. Patience during flash time prevents blistering and film shrinkage. The front fender and doors are covered evenly down to their lower edges. She watches the recessed corners where protection is easily missed. The rear quarter receives another light primer coat. Areas once heavily corroded are sealed without allowing the material to run. The roof and trunk lid are sprayed in long parallel passes. Her hand speed remains steady to avoid dry areas and overloaded wet spots. Once the primer dries, she marks every low spot that remains. A uniform primer color makes panel distortion much easier to see. Body filler is mixed with hardener on a clean board. Overmixing creates air bubbles, while too little hardener prevents proper curing. She spreads only a thin layer over the areas that need correction. Filler is not a material for hiding an entire panel of rotten steel. The front fender is filled along its original body line. The spreader must move in long, decisive strokes to minimize pinholes. The door is repaired where it was struck in the past. She builds several thin layers instead of one thick layer that could crack. The area around the handle must be shaped with great precision. Even a small error in thickness can prevent the handle from sitting flush. Filler is applied to the corroded edge of the trunk lid. She preserves the panel gap so the surrounding body lines remain straight when closed. When the filler reaches the correct hardness, she begins sanding with a long block. The block creates a flatter panel than fingertips alone ever could. Different dust shades reveal the high and low areas. Dark sections show where the sandpaper has not yet made contact. She sands in a crosshatch pattern to avoid cutting grooves in one direction. This is a standard technique when shaping rod panels. The filler edges are feathered gradually into the primer. A sharp transition would remain visible beneath the finished paint. After blowing away the dust, she checks the rear door with her bare hand. Fingertips often detect subtle waves better than the eyes. She adds another thin layer of filler to the remaining low spots. Body repair is a repeating cycle. Inspect, correct, and inspect again. The car already runs, yet she spends hours on every small imperfection. To her, restoration means not only repairing machinery, but returning dignity. The woman who sold it once said the car was worth only $500. After a rebuilt engine and restored body, what do you think it is worth now? She continues sanding the trunk lid and the corners around the rear lights. Every curve must flow continuously so reflections do not break in the clear coat. The final filler layer is spread very thin and allowed to cure completely. Sanding it too early would let the surface shrink after painting. She applies a light guide coat over the filled surface. Any guide coat left after sanding reveals a low area that still needs correction. The rear quarter is sanded with a flexible block following its curve. The tool must match the shape, or the car's original contour will be lost. She realigns the trunk lid edge and the gaps between body panels. Even gaps can make an old car look dramatically more precise. The front door is refined with progressively finer sandpaper. The goal is to remove coarse scratches without sanding through the primer. She checks the front fender under a horizontal inspection light. Any wave must be corrected now because clear coat will magnify every defect. The entire body is blown clean from the roof downward. Dust hidden inside door gaps must be removed before the final coating. She wipes the surface with a lint-free cloth and dedicated cleaner. An ordinary cloth may leave fibers trapped beneath the paint. A repair primer coat is sprayed over every newly filled area. It seals the porous surface and creates uniform paint absorption. After it dries, she lightly wet sands away dust, nibs, and orange peel. Water prevents the paper from clogging and reduces deep scratches. Tiny pinholes are filled with finishing putty. Ignoring them would leave highly visible depressions beneath the glossy color. She performs the final sanding around the handles and door creases. These areas are small, but they always sit directly in the viewer's line of sight. The hood is leveled with long sanding strokes. A flat hood will reflect light in one continuous line after finishing. She moves to the rear panel and the edges around the taillights. Every sharp edge is smoothed without rounding it excessively. The car now wears patches of primer and filler in many shades. It does not look beautiful yet, but its foundation is stronger than ever. She washes the body one final time and allows it to dry naturally. Water trapped in a seam could be blown out by the spray gun and ruin the paint. Would you preserve the original white or choose a completely new color? She has selected something bold for this car's return. The windows and sills are masked again with fresh, clean film. The dusty old covering should never be reused for the finishing coats. She seals the windows, handles, and interior completely. Only the surfaces intended for paint remain exposed. The wheels and wheel wells are protected once again. Overspray on the brake discs could temporarily reduce friction. Masking tape is pressed tightly along every body edge. A clean masking line makes removal faster and produces a sharper finish. Immediately before spraying, she wipes the body with a tack cloth. It is the final defense against the smallest dust particles. The workshop floor is lightly wetted to keep dust from rising. She also checks the airflow direction before opening the spray gun. Copper orange paint is mixed with hardener and reducer. The ratio must be exact so the color lays evenly and cures on schedule. The mixture is filtered through a paint strainer before entering the gun cup. One tiny particle could block the nozzle or leave a spot on the hood. She sprays a test panel to confirm the final shade. A color under workshop lights can look very different outside. A thin tack coat is applied across the hood first. It gives the following coat something to grip without creating runs. Orange color begins to cover the front of the car. The Cielo seems to be receiving an entirely new personality. She moves the spray gun steadily from one edge to the other. Stopping in the middle of a panel would create a dark band that is difficult to correct. The roof receives evenly overlapping passes. She maintains a constant distance so the paint particles settle smoothly. The sides are sprayed from top to bottom, one panel at a time. A consistent sequence keeps the wet edges connected and prevents mottling. The front and rear doors gradually turn copper orange. All signs of the old patchwork repairs disappear beneath one uniform color. The rear quarter and trunk lid are sprayed from an angled position. She controls the gun carefully so paint cannot build up on the curved edges. She allows the correct flash time between coats. Rushing can make the paint film wrinkle or trap air bubbles. The second color coat increases coverage and depth. The metallic effect begins to appear as light reaches the surface. She checks the shade from several angles before the final pass. Metallic paint can stripe easily when the particles are not oriented evenly. A light orientation coat is applied to settle the metallic particles uniformly. This prevents bright and dark clouds from appearing when the car is viewed at an angle. After the color coat, clear coat is sprayed with slower hand movement. The film must be wet enough to flow smooth, but never heavy enough to run. The hood reflects the workshop lights like a copper-colored mirror. At this moment, every hour of sanding finally begins to repay her. She finishes the door edges and lower body sections. No hidden corner is ignored simply because the camera cannot easily see it. The final paint coat is complete, but she still cannot touch the car. The finish needs time to stabilize before the masking can be removed. Once the paint is dry enough, she begins peeling paper from the body. Each strip of tape is pulled back at an angle to protect the fresh paint edge. The copper orange color is fully revealed under natural light. The $500 car now carries almost no trace of the overgrown field. She wipes the surface gently with a soft cloth and very little pressure. Fresh paint still needs more time to reach its full hardness. The lights, seals, and door handles are reinstalled. She checks every gap so each part opens and closes naturally. The masking around the glass is removed section by section. Crisp borders prove that the preparation work was done correctly. She returns to the cabin that was once filled with waste and damp odors. The seats are clean, the floor is orderly, and the dashboard can function again. Each door is opened wide to inspect the locks and seals. A solid closing sound shows that the body alignment has improved. She reinstalls the seats and checks the safety belts. A beautiful car without safety can never be called complete. The hood opens one final time for an oil, coolant, and wiring inspection. No new leaks have appeared after the first full heat cycle. The headlights and taillights illuminate one after another. Charging voltage is stable, idle is smooth, and engine temperature is normal. She sits behind the steering wheel and rests a hand on the gear lever. Years ago, she dreamed of having a car of her own. The Daewoo Cielo slowly drives out of the workshop under its own power. Once $50 scrap, it has become proof of perseverance. Who should she sell this car to? And what price should she ask? Thank you for joining NeoTech for 1000. See you at the next revival.